Right now, we're 100 feet underwater off the coast of North Carolina. That may just look like a pointy rock, but it's actually a multi-million-year-old megalodon shark tooth fossil.
Yeah, so here in NC, this is Meg country. I mean, this is one of the top spots on Earth for finding megalodon teeth. Megalodon is probably the most famous extinct group of shark, and they are extinct, despite what some sci-fi movies may have you believe. There's no chance that megalodon is still hiding in oceanic trenches anywhere. It's clear it was a carnivore. It's clear it was a predator. You don't have, giant steak knife teeth with serrated edges if you're not eating meat. So they were these extremely large, probably the biggest macropredatory sharks that ever lived.
Megalodon has to eat a metric ton of food every day. That's like having to eat your Ford F-150 every other day.
To learn more about how megalodon lived, paleontologists turned to fossils. But for sharks, the fossil record is a little different.
Well, one of the big differences between sharks and other animals is that they have no bones. Their bodies are composed of cartilage, which is like a styrofoam frame for the body. It's strong, it's bendable, but the second that they die, those cartilage prisms, they just detach and everything disintegrates.
The only really hard part of a shark is the teeth. Teeth are really, really good at fossilizing.
And sharks lose a lot of teeth during their lifetime.
It's been estimated that sharks can lose as many as 35,000 teeth during the course of their lifespan. When I die, if hopefully I enter the fossil record, I only have one skeleton to give. Sharks' teeth are constantly being lost and constantly being replaced. So because of that, we have an incredibly rich, incredibly dense fossil record of sharks' teeth. But that's it. We don't have the bodies, we don't have the rest of the skeletons for the most part. And Megalodon certainly, we don't have jaws of Megalodon, it's all reconstructed. The jaws we have at this museum, teeth are real, the jaws are reconstructions. Basically all that we know is based on this tooth record.
One of the best places in the world to find megalodon teeth? You guessed it, North Carolina.
Now, is that a result of prehistoric North Carolina just having been swarming with megalodons to the exclusion of other places? No. Megalodon was a globally distributed species. We know it was living in oceans, probably mostly in equatorial regions around the world in the late age of mammals. The reason that we are so rich in megalodon fossils has to do with sort of basically the peculiarities of geological history and the biases that go into our view of the fossil record.
Fossils aren't easy to find. A lot of the fossiliferous rock in the world has been destroyed, and existing fossils are often buried deep underground.
So you need to have rocks of the right age that, one, still exist, two, are exposed at the surface, and three, are the right kinds of rock, because if it's like igneous or metamorphic rock, you're not going to get fossils in there. If you're looking for a marine animal like Megalodon, it needs to be marine sediments.
And coastal North Carolina checks all of the boxes.
There are two major sources of Megalodon fossils in the state. The biggest one historically was these giant phosphate mines out east near Aurora. For a lot of the 20th century, these were accessible to fossil hunters in the public, amateur fossil collectors, as well as to paleontologists.
The layer of rock the mine is targeting is from the nearshore marine environments where a lot of biodiversity occurred. So it contains a dense concentration of marine fossils. And mining accelerates the rate of new fossiliferous rock being exposed. But there's another natural process that unearths fossils in coastal North Carolina.
A lot of this megalodon-bearing rock is not at the surface, but just below it. And so how can we get at it? Well, natural waters get at it.
Rivers like the Tar and Cape Fear cut through this subsurface rock, washing out fossils and redepositing them on the riverbanks and beach.
That rock is also exposed as you get the drop-off off the coast. And so wave action on the coast is eroding the edges of those fossiliferous layers, which we call the strata, and washing them then into the ocean. It's the right combination of factors to have lots of megalodon teeth where we as humans can get them.
Remember that diver who found a fossilized megalodon tooth earlier? That was Captain Shane Gaither, who lives on his boat in Carolina Beach.
Here in our inlet, as you're going out to the ocean, on the bank, there's actually a clay ledge at low tide you can see, and it looks just like the ledges underwater.
Skilled divers like Shane head out to these eroding underwater ledges to find shark teeth and other fossils.
There's a lot of different conditions you can find shark teeth while scuba diving. Where we are in North Carolina, it's typically pretty far offshore and on average 100 feet of water. So it's not for the novice diver. It's very rare that you see a whole tooth laying exposed. It's typically, pretend my thumb is black. That's all you see of that tooth, but that sixth sense kicks in and you investigate and you fan and whew, tooth. Let's see what we got. So we got at least one really good one. That is a megalodon. It'll clean up nice. This is a broad-toothed mako. Kind of we call that a fragalodon, fragment of one. This is interesting. That's not a rock. That is actually the ear bone of a whale.
We're not just finding megalodon alone. There's this whole ecosystem of fossils from those same strata, those same deposits where they're found that show evidence of interactions with megalodon. Particularly these early sort of mid-sized whales, there is abundant evidence actually of attacks by megalodon on these animals.
Since fossils are the only remnants of megalodon we have, studying them helps researchers understand more about these massive ancient predators, like what they ate. And fossil donations to the museum allow for new discoveries. A donated megalodon tooth with a unique slit down the middle expanded our understanding of what megalodon might have eaten.
On most megalodon teeth, right here in this surface right here, it's curved, it's convex, or it's flat. But on this tooth, and if I can get the lighting right, you can maybe see it goes in right there. That makes us think that whatever caused this deformation, it started early on at the base of the tooth when it was still forming.
Historical illustrations of similarly misformed shark teeth helped Haviv come to the conclusion that the trauma was likely caused by something spiky that the megalodon ate.
It would make sense that they weren't just eating whales, but they probably ate a plethora of different animals. If they found a meal, they were going to eat it. They had to because they had to eat a metric ton every day.
We are reliant on partnerships with the broader community of anyone who is out there looking for fossils. As a state paleontologist in North Carolina, I can't be at every river cut every day where there was a rainstorm and maybe a new fossil washed out of a riverbank.
And so donations like this are really vital towards allowing us to share with you and unravel the mysteries of our natural world.
Thanks y'all for watching this video, and if you want more where that came from, check out our channel, Sci and See. Stick around.